10.5 is about hyperbolas. Notice the major difference between hyperbolas and ellipses is the plus sign here and here. And again, as well, too, look, x squared and y squared now switch. Depends on what comes first. And notice with our a squared, always stays first. Okay, so vertices is still plus or minus a, nothing difference there. And your foci is still plus or minus c, there's no difference there. But again, we've got asymptotes here, depending on which one you're talking about and how to find them. So again, a hyperbola center at 0, 0 has vertices plus or minus 4, 0 and one focus of 5, 0. What is the standard form of the equation? So we know our a equals 4 and our c equals 5. So again, what we're going to do is kind of Pythagorean theorem type of thing. Is c squared equals a squared plus b squared. And that's going to help me to write my equation. So 25 equals 16 plus b squared. Subtract 16. B squared equals 9. Now, I don't really need to take the square root because it really doesn't matter. I just want to write the standard form. So again, what we're doing here is because this is under the x, that means x goes first. So x squared over 16 minus y squared over 9 equals 1. Now to sketch it, we're going to use both what my a is and what my b is in this case. My a is 4. It's under the x, so I'm going to go 4 right and left. 1, 2, 3, 4 on the x-axis here. Now, the 9 is under my y, so I'm going to go up 3, because the square root of 9 is 3. 1, 2, 3, and put dots there. And that's going to help me to make this box. And this is how I'm going to draw my graph. There are equations of these asymptotes, and we'll get into that in a second. But this is the easiest way to graph them. Make the box, okay? And now just draw your asymptotes right through the corners, right from the center. And that's going to help me draw my graph of these asymptotes, or of the hyperbolas. And I'm going to start right here at my vertex, and you're just going to come as close as you can to the asymptotes without ever touching them. Because remember, that's what the definition of an asymptote is. And there's your hyperbola. Example 2 is asking what the vertices, foci, and asymptotes of the hyperbola are with this equation. Again, notice it equals 63, so what I have to do is get that equal to 1, because all hyperbolas and ellipses equal 1. So 9 divided by 63 is y squared over 7 minus x squared over 9, and I'm just reducing fractions, equals 1. So now we have a squared, which is 7, and we have b squared, which is 9. I need to know what c squared is. So again, Pythagorean theorem-ish type of thing, so c squared equals 7 plus 9, which is a squared plus b squared. C squared equals 16. Square root both sides, c equals plus or minus 4. So that's where my focus or foci is, plus or minus 4 in this case. So my vertices, again, so we have this here. It's under the y, so my vertices are 0 plus or minus radical 7. And my foci, again, we just found it is plus or minus 4. Same axes as the vertex, so 0, plus or minus 4, or my vertex, or my foci, I'm sorry. Now to find the slopes of your asymptotes, okay, you want to go back to your original thing that we copied down before example 1. And it's really because y is first, it's plus or minus, okay, a over bx times x. So in this case, what's my a? My a is 7. Actually, it's the square root of 7. A squared is 7. Right here. So a is square root of 7. So my slope is plus or minus the square root of 7 over b. Well, b squared is 9, so b is 3. So my equation of my asymptotes is y equals plus or minus radical 7 over 3. Now, to draw my hyperbola, you don't really need the equation of the asymptotes, but it's nice to know. My a is plus or minus radical 7, so that's roughly 2 point something. So I'm going to go up to 2 point something and put a dot. Somewhere in between. It really doesn't matter. This isn't exact science here. Okay? And then your other one is the square root of 9, which gives me plus or minus 3. So 1, 2, 3, I'm going to go 3 on the x-axis because that's what's underneath the x, and put dots. And I'm going to connect these, again, in kind of a rectangular fashion as best as I can. And it sucks when it's in between. Okay, and then draw your asymptotes. And again, they will have the slopes that we just defined. But in order to draw it, it's really not a necessity, because you just go through the corners of the boxes. So when I'm drawing it now, again, start at the vertex, just get it as close to the asymptotes without touching as you can. And there's your hyperbola.